Today we're going to be starting our study on rate, ratio, and proportion. This topic can be found in Chapter 5 of your textbook. Today we'll be doing Lesson 1, Investigation 1 on ratios. Our goal today is to use ratio language to describe a relationship between two quantities. Please pause the video and take a moment to set up your notebook paper so it looks like the one on the screen. The first thing you should be asking yourself is, what is a ratio? A ratio is a comparison between two or more numbers. We'll be looking at three different types of ratios in this unit: part to whole, and rate. Today we'll be focusing on the first two types of ratios, part to part and part to whole. A part to part ratio looks at two portions of a group. A part to whole or total ratio compares a portion of the group to the entire group. Again, take a moment to pause the video and record these notes so that you recall the different types of ratios. Let's try some examples. Let's find the ratio of apples to pears. First thing that I want to do is identify my ratio in words. The ratio that I'm finding is apples to pears. Since part of my group is apples and part is pears, I know this will be a part-to-part ratio. There are 2 apples and 1 pear, so I'll express this as a 2-to-1 ratio. There are 3 different ways to write a 2-to-1 ratio. I'm going to show you the 3 ways now. All 3 ways are read as 2-to-1. 2-to-1, 2:1, and 2:1 are all read as a 2-to-1 ratio. Notice that 2 is always coming first in these ratios because apples came first in the ratio that they asked for. Pears came second in my word ratio, so the 1 that represents the number of pears that I have is coming second in my ratio. I must have both numbers in my ratio. Let's look at another example. Here I'm asked to give the ratio of the longer line to the shorter line. Since they've asked for the longer line first, I know the number representing my longer line will come first in my ratio. When I look at these 2 lines, I notice that for every 2 units of the longer line, I have 1 unit of the shorter line. This will again be a 2-to-1 ratio. Take a moment to write down the different ways to express ratios and some of these notes so you can refer to them while studying. Then press play so we can try some examples together. This question asks us to look at the keyboard. It says, what's the ratio of white keys to black keys? White keys to black keys. Since white came first, I know I'm going to be writing white first in my ratio, or be writing white on top in my ratio. For this one, I'm going to write white on top. I need to be consistent with the way I position my numbers, so I always start with a word ratio, white to black. In order to write my ratio, I need to count how many white keys there are and how many black keys. Take a moment to count the keys on the keyboard. There are 14 white keys, and there are 10 black keys. This is a 14-to-10 ratio. You might be thinking that this looks like a fraction and that you know about reducing fractions. We can also reduce this fraction to make an equivalent ratio. 14 white to 10 black keys can be reduced to 7 to 5. Let's look at how that connects to the picture. If I cut this keyboard in half, I'll notice that there are 7 white keys on each side and 5 black keys on each side. That tells me that a 14-to-10 ratio is equal to a 7-to-5 ratio. Either answer, 14-to-10 or 7-to-5, would be accurate answers for this question. Let's try another question with the same keyboard. This pattern of keys is repeated on larger keyboards. How many black keys would you expect to find on a keyboard with 42 white keys? Take a moment to write your word ratio and a ratio of black and white keys to get started. Let's be consistent and use the same word ratio that we used in the last example. You should have written that this is a white to black ratio and that our ratio is 7-to-5 because there are 7 white keys for every 5 black keys. They want to know how many black keys there'll be when there are 42 white keys. Where will 42 go in my ratio? 42 needs to go on top because that's where I'm recording my numbers of white keys. The information I'm looking to find is how many black keys will there be. There are some different ways to look at this example. I can look at it as equivalent fractions. I can say, how can I get from 7 to 42? And you might tell me that I'd multiply by 6. Well, if I'm going to make an equivalent ratio, you know that I need to do the same thing to the denominator, multiply by 6. Another way that I can look at this is to look at my keyboard and say that this portion of my keyboard, which was a 7 white keys and 5 black keys ratio, is going to be repeated until there are 42 white keys. That means I'll need 6 keyboards. Here's 1, 2, 3, 4, 5, 6. If every one of those 6 keyboards had 5 black keys, how many black keys will there be in all? Counting by 5s will tell you that there will be 30. I want to answer this question with a label. How many black keys would you find on a keyboard with 42 white keys? You would find 30 black keys. Take a moment to record your notes for this example. For this next example, let's find what is the ratio of the black keys to all of the keys. Black keys to all keys. Well, since I'm comparing part, which is the black keys, to all of the keys, this one's going to be a part to whole ratio. Again, let's start with the word ratio. This time we're doing black to all. So part to whole. Let's count how many black keys there are on the keyboard. There are 10 black keys on the keyboard. How many keys are there in all on the keyboard? There are 24 keys in all. So I can call this a 10 to 24 ratio. Again, because this keyboard seems to repeat in half, I can reduce this ratio and say that this is a 5 to 12 ratio. If you've noticed, I've divided both the black keys in half and all keys in half. So 5 to 12 is equivalent to 10 to 24. We could have again written this in different ways. We could have done black over all and represented this as a 10 to 24 or a 5 to 12 ratio. Once you've copied these examples and feel comfortable, let's move on to our last example. How many black keys would you expect to find on a keyboard with 72 keys in all? We're looking to find out how many black keys that we'll have, how many black keys, when there are 72 in all. Well, black would be part of the keyboard, and 72 keys in all is the whole or total keyboard, so this is a part to whole ratio again. So before we can find out how many black keys there would be when there are 72 in all, let's look at how many black keys there are for this entire keyboard. So we said that there are 10 black keys on a keyboard that has 24 keys. That's describing the keyboard above. We also found an equivalent ratio when we looked at just half of the keyboard, and we said that there were 5 black keys when the keyboard had 12 keys in all. From this equivalent ratio, we can make another equivalent ratio for a larger keyboard if the keyboard has 72 keys in all, because that's what we're looking at, a keyboard that has 72 keys in all. What we want to find is how many black keys there will be. So just like here, when we did from 24 to 12, we divided by 2, we're going to say, how could we get from 12 to 72? Well, 12 times 6 is 72, meaning there were 6 sections of the keyboard. So if there are 5 black keys on each section of the keyboard, how many black keys will there be if I have 6 sections? I would multiply 5 times 6 equals 30. Don't forget to write your answer with a label, 30 black keys. Remember to pause for a moment to look over these answers when you're not sure, to make sure you fully understand. Okay, now it's time for you to assess how you're doing. Here's some examples of Mercedes and a beaded necklace that she made at summer camp. I'd like you to try these examples on your own. See how you're doing. If you understand, then you can stop after you've completed these activities and submitted your answers. If you don't understand, click the next video to try a few more with me. Good luck, and remember, today you're trying to describe the relationship between two quantities using ratio language.